Today we'll see some more concepts. Just let will go for a brief review for 2-3 minutes. Then we can go to the current day topic. So the blockchain was first blockchain was first proposed in 2008 as part of the Bitcoin application and implemented in 2009 by Satoshi Nakamoto. And no one knows who is this person. Blockchain is the core mechanism for the Bitcoin. That is, Bitcoin will work on top of the blockchain, and blockchain is the backbone for the Bitcoin. Blockchain is the first decentralized digital currency, and it does not rely on the central government authority. Any central authority will not be having the responsibility of holding the currency and all. However, it is a completely decentralized authority. And in Bitcoin, there will be a total of 21 million mined and unmined coins will be there. Whatever the transactions will happen, that will happen within this 21 million coins only. So is Bitcoin a real currency? So it is not a real currency. Actually, it is a cryptocurrency. Actually, this particular currency don't have the legal tenderness or exchange legal tenderness ability in various countries. So very few countries have accepted it as a legal tender, but actually it is completely virtual in nature, and obviously if you want to utilize the Bitcoin, it will be one Bitcoin will be equated to the US dollar, and if you want to go for exchanging, then the exchanging rate will be charged on that, and the amount will be returned in terms of dollars. So can it be collected, traded, and spent? Obviously, you can do it. You can collect the Bitcoins, and you can also trade the Bitcoin, and also you can spend the Bitcoin, provided the business should also accept the Bitcoin as the currency for acceptance. So here the Bitcoin currency and payment system, the person A, if he want to own the Bitcoins, he cannot directly get the Bitcoins. Instead, his local currency has to be converted to the Bitcoins via money exchangers. So these money exchangers will be there who will create this particular Bitcoin and will give them. So if you look at in Indian currency, one Bitcoin today is around 32 lakhs and 76,000 something. So one Bitcoin means that much is the cost. So if you have that much money, you can get one Bitcoin. Okay. And the lowest denomination to the Bitcoin is said to be Satoshis. Okay. So it is just like 1 rupee will be having 100 paisa. Like that, lowest denomination is said to be Satoshis. So this Bitcoin will be taken to the person A. This will be handed to the person A. Now, via the Bitcoin clients, person A can send to the person B. Now, whenever the person B receives the Bitcoin, he cannot directly use it. Instead, if this is not a legal tender in that country, he cannot directly use it. Instead, he has to go for money exchanger. Again, some commission will be deducted here, and they will convert it into the related dollars, and it will be sent to the bank, and from the bank he can collect the person B can collect the money. Okay, so this is the general way of doing the Bitcoin transactions, and this article I asked you to read in the last lecture, that is Bitcoin, the new Hawala. This was written by the former director of Indian Statistical Institute, Kolkata, Professor Bimal Roy. He and his research scholar, Atul Biswas, they have done some research work on this in 2017, and they have projected how Bitcoin is going to become a new Hawala in near future by observing the trend from the demonetization onwards that was happened in 2016 November. So what is the exchange rate on the day of demonetization, and what is the exchange rate of Bitcoin to the dollars after 3 months, 2 to 3 months of the demonetization in India. So they have given a prediction that this will be used as Bitcoin may be used as a Hawala system. That means the black money in the country may go out of the country and will come back to the country in the form of Bitcoins. So they have expressed this doubt in this particular article by showing the statistics. So because of that, they have faced several problems, and also the Ministry of External Affairs and Home Affairs, Intelligence, and ED. All this was focused on this particular article because the Indian Statistical Institute director means it's not a joke because they are direct advisor to the Ministry of Finance. So whatever the budget sessions, whatever the budget planning, total statistical works will be done by the Indian Statistical Institute itself. So that is the reason this article was taken by the various ministries seriously, and they worked on that. So that is the reason in 2018 in February in the Parliament session, that is in the budget sessions, then Finance Minister announced that Bitcoin is not a legal tender in India. So if it made a legal tender, Bitcoin has a made legal tender, then all the black money, whatever the black money went out of the country because of the demonetization may come into the mainstream as a white money. So that is the reason the Bitcoin is not a legal tender that was made at the time. And now also it is not a legal tender in India. However, you can do Bitcoin exchanging or Bitcoin trading or Bitcoin mining. So to earn money. But Bitcoin purchasing and exchange, what you call purchasing and doing some what you call purchasing of items or some this kind of things. So for this, Bitcoin is not a legal tender. And recently, RBI is coming up with some new cryptocurrency to be used in the country. So this is up to the yesterday. One Bitcoin value is 27 as on 27th September. So one Bitcoin is equal to 32 lakh 46,572. Assume that if you got a 15 lakh package or this one 16 lakh package, then if you for 2 years if you have been given one Bitcoin, that is sufficient for you. So that is the amount it is accumulating. That means now the one Bitcoin is maybe of $16,000 to $20,000. At the time of demonetization, the Bitcoin cost, exchange cost is around $600 to $650 per one Bitcoin. But after 2 or 3 months of the demonetization, it went up to $2,800 for one Bitcoin. Then in the November 17, it was went up to $10,000 per Bitcoin. But in 2018, after the announcement of that Bitcoin is not a legal tender, in March, in February ending in March, it was drastically calmed down. So that is, you can see the trend over there. So we have seen the discussion on the blockchain architecture. The blockchain consisting of various blocks, and whatever the first block is said to be, whatever the first block is created, that is said to be the genesis block, that is the starting block. Okay, every block consisting of two parts. One is block header and another is block body. The block header consisting of the metadata about the block. So what is the metadata? Block version, parent block hash, Merkle root, and timestamp, n-bit, nonce. These are the various metadata about the particular block. Nonce means it is a random number, especially used in creating the hash values of the particular block. So how strong this nonce is, that much strong is the hash value, and also it totally affect the mining process. So this nonce in general will be generated by the blockchain framework. You won't create this nonce. Nonce will be generated by the blockchain framework, and at the time of creation of the block, this nonce will be added to the hash of the previous block, and the resultant hash will be given to you. Now you are supposed to find what is the nonce to get the current block hash. So if you can accurately predict what is the nonce, then you will be given the opportunity to create the block. So this process is said to be the mining process. So if the nonce was taken from a very large, densely spreaded distribution, there is no alternative that only the way of identifying nonce is only by randomness. Just only by randomness you can identify. But according to the randomness, according to if you go for searching in random way, then finding the nonce value, exact nonce value that will come to, that will be equal to the given hash value is a very very difficult process and also time consuming process. So that is the way this nonce will take a major role. For example, if the nonce value is a small number, then you can simply make a for loop, okay, and you can go through the identification of the nonce. But if it is a large value, then it is very very difficult. Only randomness is the only alternative. Let us assume that you have block 0, which is the genesis block, and block 1, block 2, block 3, like that. So every block, each block has, one is block header and second one is block body. Now each block has block hash. Block hash is equal to the hash of the block header and block body. So assume that this is the blockchain you are having. Assume you want to add new block B4 to the blockchain. Now what you are supposed to do? So assume that you are the miner. You are supposed to, you have been given chance to add or you want to participate in the creation of the block and adding to the blockchain. Now what you know is known, or we can say the blockchain, what it will do is it will create a hash. So it will use SHA 256 of the B3. So this B3 hash, it is hash of B3. To this, this nonce will be added, so that you will get the hash value. Now the hash value is given to the miner. Now miner task is to identify the nonce value. Clear? So already every user or every miner will know the what is the previous block. So previous block, if they know, they will be knowing the previous block hash. So this is known. That means hash of block 3 is known and hash value will be given to you. Now you are supposed to find nonce. So if the nonce is, say for example, assume nonce is 17. So what you can do is, I can make a for loop for I is equal to 0. Okay, I less than some 100, I plus plus, okay. And same thing, I can check that if, okay, hash of B of I equal to the hash value given by the system, then return I. So with this, I can easily come to know what is the nonce generated by the system or the blockchain framework. So whenever I submit this back to the system, if the nonce value is the correct value, then automatically you will be getting the chance to create the block. See, if the nonce is very small, it is very easy to identify just by simple for loop. That is the reason the nonce will be a very big number. You don't know how much length it is. It will be almost around 2 power some very big number, 128 like that. A very big number will be there. So when the very big number was, that means a random number was taken from a huge, densely spreaded distribution, then you cannot use a for loop. And at the same time, you need to perform the cryptographic hash values. That many cryptographic hash functions you are supposed to do it. So usually, if you look at the time complexity, one hash value will be generated in order of n times, where where n is the number of bytes that you are going to pass into the hash function. So if B3, if you are sending 128 bytes or 256 bytes, so order of n, that much is the order that it will take for completion. That means if you are running 100 times means 100 order, that is 100 order of n, that is a constant value, only this order of n only. But a nonce, if it was taken from a large distribution, large set of elements, then it is very, very difficult for anyone to identify what is nonce. So for this, normal computers will not work. So you are supposed to use from specific computers or specialized computers. There are computers like CPU. So CPU may be having uh, maybe 8 cores or maybe with 3.2 gigahertz. So, but these many instructions, see 3.2 gigahertz just means frequency is 3.2. To execute one instruction, it will take one frequency is equal to 1 by time. So time is equal to 1 by frequency. You can make 1 by 3.2 gigahertz. So that means within 1 second, that many instructions will be executed. But actually, 3.2 gigahertz is also a very small count because if the nonce was taken from 2 power 128 or 2 power 256 or like that. So what is the another solution? Can you use any other hardware? Obviously, you can use GPUs. So, but GPUs will not do specific, will be used for the things, but they are very costly. And maintenance is also required. Generates more heat, okay? Need cooling. Like that, so many problems are there with GPUs. So that is the reason they went for ASIC computers. So because ASIC computers are application specific, okay, integrated circuits. So here the application specific means here the main thing is to generate the hashes. The main application is to generate hashes. So these ASIC computers are especially meant to generate the hashes. Okay, so this ASIC computers will be used, but still sometimes if the complexity of the nonce is increasing, this ASIC computers will not be sufficient. So you require group of ASIC computers. Okay, group of ASIC computers. So this group of ASIC computers is nowadays calling it as mining stations. So these mining stations will be consisting of a array of ASIC computers, especially used only for mining purpose. So that is the reason if you look at a one CPU, maybe it will work on 230 volt in India, okay, and maybe you will be having 45 to 90 watt adapter, okay. While coming to GPU, they are a little bit higher version, like maybe they may work on 450 watt kind of thing. But ASIC computers, you require megawatts to gigawatt power, especially like stations require gigawatt power. That means a specific substation, electricity substation must be attached to these mining stations. Otherwise, it is not possible for running all these ASIC computers. Okay, so that is the reason the mining process is not eco-friendly. This is somewhat harmful. It will be harmful to the environment also. It will be harmful to the environment also. So that is the reason, since this particular nonce identification and hash value is part of the proof of work concept used by the Bitcoin. So it is part of proof of work concept, which is used by Bitcoin. So that is the reason nowadays, whatever the uh, new blockchain frameworks are there, which are public blockchains, they are looking for alternatives to the proof of work, such as proof of stake, proof of elapsed time, proof of authority, etc. So these are the most suitable consensus or mining algorithms that can be fitted for the public networks. Since Bitcoin is a public blockchain, anyone can join the network at any time. Anyone can leave the network at any time. So that is the reason you will be having this parent block hash, Merkle root. So Merkle root is one which is the hash of all the transactions that are included in the block body. So whatever the transactions included, all these transactions will be arranged in a tree fashion, which is called a hash tree, and the root hash that will be placed here. So we'll see this Merkle tree in detail afterwards. So here is the block 0 of the Bitcoin, and here this is the genesis block of the Bitcoin. This is the address I have given. So this is the block 0. You can see this block was mined on January 3rd, 2009 at 11:45 p.m. GMT plus 5:30 by unknown. You don't know who is that, because Satoshi Nakamoto means no one knows who is this person. It currently has 702,396 confirmations on the Bitcoin blockchain. So the miner of this block has earned 50 BTCs, 50 Bitcoins, because of the creation of the block. So the one, if you create a block, you will be given a reward of 50 Bitcoins at the time in 2009. Make note of this. For every 4 years, this reward value will be halved. That means will be halved means here it is in 2009. In 2013, the reward value is 25 Bitcoins only. In the 2017, the reward value is 12.5 BTCs. In 2021, currently the reward value is 6.25 BTCs. The reason is, as the years grow, they have a vision that as the years grow, the Bitcoin exchange also increases. Exchange rate also increases. So when the BTC was introduced, it may be of one BTC is equal to $50 or like that. But now one BTC is around $18,000 to $20,000. So that is the reason this value increases. So for every 4 years, if you create a new block, what will happen is this creation of new block, the award or the reward will be given. The reward will be given because they have spent this much energy, gigawatts of energy in mining this particular block. So if you look at in our household, in the domestic electricity, so if you spend one or two AC and one cooler or some this kind of things during summer, the electricity bill will come in too high. But they are running gigawatt of electricity. They require that much electricity. Obviously, they need to spend a lot of money for that. So that is the reason. Once they create a block, they will get around 6.25 BTCs as per the current standard. So this is the main reason why they will get this thing. So now if you look and observe the hash of this block is this one. This is the block hash. And how many have confirmed that this is a valid block? So 70 to 396, this many users confirmed this is the valid block. Timestamp, this is timestamp. Height 0, this is the first block. Minor, you don't know, minor address is not placed here. Number of transactions 1, difficulty 1. This is the elementary thing, because as the difficulty increases, you cannot predict what is the nonce value. So here nonce value can be predicted because the difficulty is very low. So you can see here the nonce is this much. This is the nonce value. Now this is not the nonce value. If you look at any other block, like I am going to show you one more block, like 4,38,807 block. This is the first block I am showing here, block 0, and this is the block of 438807. So in this, if you look at what is the nonce, so this is the nonce you will be having. It's completely different nonce. And the difficulty, if you look at the difficulty is this much. Okay. That means the complexity of identifying this nonce increased. While coming to the transaction volume is 0 BTC, block reward is 50 BTC, and fee reward, there is no fee reward for this because it's first transaction, so 0 BTC. Like that, you can type whatever the number you want of block number. You can say, for example, you can search here, like for example, 1. If it is available, you will get it, 3,000 something like this. So it will ask you what type of block you want, whether you want BTC block or Ethereum block or BCH. So BTC block, that is Bitcoin block. So you will get 538807 block number, and you can also see the thing here. And here it was given here. Look at miner slush pool. See, this slush pool is the miner who created this block. Yes, slush pool is nothing but this is the miner who has taken the pooling of the hash powers of various miners, because one person cannot maintain this much ASIC computers, this many ASIC computers. If I have one ASIC computer, I can collaborate with one miner organization. So according to the computation I did, they may give us some amount, just like collaborative work. Because one person cannot purchase this many ASIC computers. So instead, what I will do is in a distributed way, the work will be distributed, and I will do some work on my ASIC computer. And how much work I did, based on that, that miner will give us, the mining organization will give us some money in terms of bitcoins. So that is what we call collaborative work, and we can also call them as mining pools. Or this group of ASIC computers or mining stations are also considered, are also said to be mining pools. Okay, so that is the reason here. This is the miner who mined this block. So like that, you can see whatever the block you want, because it's a public blockchain. You can come to know what is the details and all. If you look at this block, 538807 block. So what is the transaction happened? This is the transaction happened. This is from Coinbase. You got this amount. This is the transaction hash, and this is also transaction hash. So 11.38245,190 BTCs they requested for, and these are the splitting of these. These are the denominations, we can say. So how these denominations will come actually? Just to think of bank. So bank, if you go to a bank, then there will be a cashier section will be there. The cashier will be having several denominations, like 500 rupees denomination, 2000 rupees denomination, 200, 100, 50. So these are the various denominations. So cashier at the beginning, he will come with some cash to the cash counter, maybe around 30,000 or 40,000, depending upon the bank and its availability. He will come with some amount to the cash counter. So obviously, from the beginning of the bank, many transactions will happen, like deposits may be happened, maybe withdrawals may be happened. So if the deposit was happened, and the cashier will maintain the deposits also, and if anyone asks for withdrawal of around 5,200 rupees, so for this 5,200 rupees, cashier will not print new currency. What he will do is he will pick the denominations which is required for the 5,200, which will become 5,200, and those denominations will be given to the withdrawal. You just think of the scenario. In the same way, if this 11.38245190 BTCs are there, is requested, then this much cumulative amount will be picked up from the unspent transactions in the blockchain. So this is a transaction in which 0.001549119991 BTCs are there. This is not spent because it was deposited by somebody. It was there with the cashier like that. So this denomination was taken. So finally, certain denominations will be picked from the blockchain which are unspent, so that cumulatively it will become 11.38245,190 bitcoins. So once this was happened, then this amount will be sanctioned, and thereby the one who requested for this amount will get sufficient bitcoins, that is the required bitcoins, plus a transaction fee for the miners for validating this particular transaction. So the transaction fee will also be added in this. You look at your fee. So the fee is like this: 0.00100000 BTC. Okay. So this much fee is added again along with this uh, requested amount. And once the miner validated this transaction, then this amount will be credited to the miner's account. So this is the way of block transaction. And in this is the block header. See, in the block header, you will be having these details, and block body, the block body consisting of the details of the transaction. So that is what the block header and block body, and this is the block zero genesis block of the Bitcoin. And as I just now discussed, the transactions that are unspent will be picked up. So which are also called as the terminology used in the Bitcoin is said to be the unspent transaction output, UTXOs. So the unspent transactions outputs, that means somebody deposited or somebody is having that particular amount in their transactions or something which are not spent. Those transactions with certain denominations cumulatively will lead to how much the withdrawer require plus the transaction fee will be added, and related amount will be picked up, and that amount will be given to the withdrawers. This particular process is said to be the unspent transaction output. And here is the block 438807. Already you have seen this particular block. So here, just to recap this example, say Ramu is given rupees 1000 to Gopal, and this transaction will be sent to several miners. So far, previously we are using the word called witness. Now, from now onwards, we are calling them as miners because we know these are the people who has to verify this transaction. Now, this transaction will be verified. The transaction verification process will happen, transaction validation, and these miners should reach to a consensus, and finally they have to create an immutable ledger. Now, in this case study, the questions to be addressed are like this. Previously, here we are calculating it as a in Indian rupees. That is, Ramu has sent Gopal rupees 1000. Assume that it is Bitcoin. Now, Bitcoin means maybe around 0.5 Bitcoin or 1 Bitcoin, something. If Ramu has sent Gopal that many Bitcoins, with a Bitcoin point of view, a cryptocurrency point of view, the questions to be addressed are like this. The following questions need to be addressed as the transaction is happening in the decentralized environment, because nothing was recorded here. No central authority is there to record this transaction. Everything is happening in the decentralized environment. Now, since it is happening in the decentralized environment, the questions to be addressed are like this. Once you understand these questions with respect to the Bitcoin, that is sufficient for you to understand the working procedure of the Bitcoin. First one is how the stakeholders know the transaction initiation. That means how the Ishwar, Paras, Radha, and Gopal, many other stakeholders who are in the business environment or in this particular network will know that Ramu has initiated transaction of rupees 1000 to Gopal. How this particular thing is known? Since the blockchain will operate in the distributed environment, and the element and the nodes will work in the peer-to-peer fashion, the best way of intimating the transaction to other stakeholders is by flooding. Flooding is the basic mechanism used in the computer networks to know about the routing tables or routing information. So simply, whatever the newly generated transaction is there, simply flooded over the network. Whoever receives the transaction will be having the copy of the transaction, and if they are the miners, they will go for verification of the transaction. I hope you got it, how to do this. Next one is how to verify identity of Ramu and Gopal. So how to check whether he is Ramu and he is Gopal. So it can be done via their public keys. So public keys are known to anyone. So public keys can be made public. So anyone knows their public key. So with that, you can come to know, okay, whether this public key is belong to Ramu or not, and whether this public key is belong to Gopal or not. How to verify the current balance of Ramu? So this will be verified with the help of the distributed ledger, because same copy will not be a centralized ledger will not be maintained. Whenever the transaction is generated, so automatically everyone will be having the copy of the generated or reference to the previous transactions. With that, anyone can come to know just by going through the hash links back to back. They can come to know whether what is the previous balance of that so and so person. How to ensure that only Ramu initiated the transaction. The identity of Ramu and Gopal can be identified with the help of public keys, but how to ensure that only Ramu has initiated the transaction? It will be done with the help of digital signatures. So by verifying the signature in the transaction, you can come to know who initiated this transaction. So this digital signature concept is widely used in the Bitcoin, especially to create the hash links and transaction links. Okay, so that we'll discuss afterwards. Since it is a digital currency, how to ensure that Ramu has spent some amount to some other user after initiating the transaction to Gopal. For example, in WhatsApp, you may receive a digital content. You can make any number of copies and you can send to anyone. How I know that you have not sent the same copy to any other person before sending to me? In digital era, it is quite common. You can take any replicas, any number of replicas of a particular digital value. Since here the rupees 100 it is not a physical currency, it is a digital one. You can send to anyone, even after sending to a specific person. This is what the double spending problem. That means same set of digital currency or same digital currency is sent as a transaction, as a sending of the amount to multiple people. Obviously, if you send to multiple people, your amount should be deducted. That is, whatever the amount should be already you are having should be deducted. But there is no centralized authority to take care of this. Since it is distributed, then how you will come to know? This is the most famous double spending problem in the decentralized environment. The Bitcoin blockchain has first to address this double spending problem. We'll see this in detail in the next lectures. How the consensus is achieved among the miners in the system. Since the transaction was flooded and Radha, Ishwar and Paras has received the transaction and they are the miners, how the consensus is achieved among these miners in the system so that the transaction is a valid transaction and can be included in the block. So for this, the solution is solving the hash puzzle, with which they will come to know they can have the authority to reach to a consensus on the creation of block. And finally, what is the benefit to miners if they solve hash puzzles? Because they are supposed to invest so much electricity in solving the puzzles. So what is the benefit they will get? They will get the benefit as the incentives. That means for creating one block, they can mine around 6.25 BTCs as per the current standards. And for verifying the transaction, they will get the transaction fees. So these are the incentives for mining the block and also for solving the hash puzzles. If the mining pools were maintained, how these incentives will be distributed, and if they have done individually, how these particular incentives will be encashed or maybe taken. These are the concepts we'll see in the next lectures.